We're beginning 1.8 here in pre-calculus, and the first thing that we want to make sure that we are clear on is when we define the domain. I know I've traditionally said it's all the x values, but to make it a little bit longer, the domain is technically all the x values in which a y value is defined. So it is still the x values, and the range are still the y values. The same thing. But this time, how do I want to phrase it? I'm going to write there exists x values. And the reason why I'm kind of switching this is because you can actually have more than one x value. Now, you cannot have more than one y value. We've talked about this idea of being a function. So you'll notice that each one of these, in example 1, there's only one x value for every one of these points. Like there's only one time that x equals -2, that's down here. But as you look at this, sorry about that, there's multiple y values at -3. What I mean by that is when y equals -3, you could have x equals this negative value as well. It's more like -2.8, but also over here at like 2.4, something like that. Now, so there's only one y value for each x value, but there's more than one x value for each y value. And if that confuses you, I'm going to give you lots of examples that explain how to find the domain and range. I've already explained it, though, that we read domain left to right. So the first time that x is defined is at this open circle, and that is at -4. I'm going to put a parenthesis there. And then we keep going to the right. There's no breaks in the graph, and we have an arrowhead going infinitely in that direction. So we go to infinity. Parenthesis always with infinity, and parenthesis with -4 because it's an open. Now range we read from the bottom to the top, and again we have an arrowhead going infinitely down, so the lowest part on the graph is -infinity. There's a negative right there, by the way. And then we have all of these defined values, and it never truly stops until we get to this open circle up here at y equals 5. And because it's open, we're going to put a parenthesis. So I think we're ready for number 2. Again, domain is the x values. We are going infinitely to the left because we read domain left to right. It's defined all the way until we get to x equals 1, open circle, union from 1 to infinity. Now range, stick with me here because I have a feeling that some of you might get confused, is we're going infinitely down. And some students want to stop once we get to this y equals 1 because it's definitely open here. However, there is a defined value for y equals 1, and that's over here at x equals 3. So it's almost like this, because it's defined somewhere, then we don't have to mention it. Even though there's an open circle here, there is a defined value for y equals 1, so we don't have to write it down. And it actually never stops. It goes infinitely up. You might remember this as being all real numbers from Algebra 2. We kind of write it that way as well. So number 3 is another example where the domain goes infinitely to the left, so -infinity, and it's defined everywhere. And even though there's an open circle here at x equals 1, there is one defined value for x equals 1, and that's down here, so we don't have to mention that break. And then same thing with instantly to the right, it's consistently defined. There's always an a y value, I should say, for each x value, so it goes infinitely in both directions. Now the range, because this arrowhead is going up, we don't want to say -infinity because it's not infinitely down. The first time that y is defined is that, looks like it's -3 to me, with an open circle. I should have given myself more space. Sorry if this is bugging you that that negative is on the line. So -3, and it's going up. And even though it looks like there's a blank space here, if we continue this arrowhead, we would fill in that space. So there's definitely a defined value. Even though the graph that you originally saw looked like there's no defined value for y equals 0, it does eventually hit there. So because of this line, there's a defined value everywhere for y above -3. So we can say infinitely up. We can confirm that because this also goes infinitely up. Let's keep powering through more domain and range. With practice, I think it all makes more sense. So again, domain goes infinitely to the left. It's negative infinity. That's a terrible infinity, but I'm not going to rewrite it. And it's undefined once we get to x equals -1, and it's undefined here, so we definitely need to mention that. There's no defined y value when x equals -1. And then union, it's defined immediately to the right of x equals -1, defined, and it stops once we get to 5. If I'm reading this graph right, 1, 2, 3, 4, 5, the x value. Now, this is tricky for the range, okay? Because some students notice this point first, and they say, oh, well, we have to start at -3. That's the lowest point on the graph. Yes and no, because don't forget, as I have been trying to allude to, is look at the entire graph. This graph does go infinitely down. Even though you did not see it over here, this arrowhead continues infinitely, and it will go to negative infinity. And again, you don't need to mention this y equals -1 because there's a defined value here, and I don't like that this does this, and over here. So we don't have to mention that. We also don't need to mention this y equals 1, even though it's open, because there's a defined y equals 1 somewhere over here. Now, if I'm looking closely at that graph, it looks like about 3.5 as your upper bound for your y's. And I meant to switch back to colors, but I'll just switch colors right now. Yeah, I hope this is all making sense. Again, please pause the video, rewatch it, email me if you have questions, and be prepared to come to class with questions on when I see you. Here's another domain where we read it left to right. So -5 is your first. I already gave away the parenthesis. We don't need to mention -1 because there's a defined value at x equals -1, and it goes infinitely in that direction. So we go to infinity there. Now your range, you want to only look at this value. I told you, in number 4, we didn't really look at this one because we had an arrowhead down. Well, in this problem, we don't have any arrowheads down. So now that's a starting value at -3. And even though there's a break right here, there's a y value defined over here. Same thing with this. There's a break, but there's a defined value. And we don't even have to mention this because this is going to go infinitely up. So you have to keep the whole picture in mind while you're reading this. And I'll switch colors one more time. With practice, this will make more sense. Infinitely to the left, I see an arrowhead there. I hope it's clear on yours as well. It's going infinitely in that direction. Even though there's a break, it's a defined value at x equals -1. This, however, is definitely a break. When you have a vertical asymptote, we cannot include that. Until I gotta squeeze this in to 4, and then 4 to infinity. Sorry, I'm writing this small. Hopefully you can see all of my work there. And then the range, this time, because of these two arrowheads, and this one as well, it does go infinitely down. As long as there's a defined value, definitely defined. You might say, oh, there's a break right here, but there's 3 other times that y equals 1. So we don't want to put that break there. You might be saying, oh, well, there's a break right here. I would say yes. Has a defined value where y equals 3. Looks like it's over here. So even though there's several holes and breaks in the graph has a y value everywhere on this problem. So the range is negative infinity to infinity. Okay, so I'm going to give you the general graph of these, and then I'll probably pause the video and continue on. These are a lot of notes. So each one of these has, y and x-axis. So right now I'm just giving you the typical function. So f of x equals c, that is just a constant graph. Might be helpful for some of you to write it as 0x plus a constant, because 0 times anything is 0 plus c. So it's pretty much c is your y-intercept, and your slope is up 0, right 1. I don't know if this is helpful at all. But the domain on this problem is just all reals. Now, for anybody curious, the range on this problem, I know that your paper doesn't have a range on it, but I might as well just give it to you. This is not an interval. The range is always that constant. And whenever you're just giving a numerical value, typically in math we put it inside of braces to distinguish that it's not an interval. It's just one numerical value. I kind of gave away this 0x plus c earlier. This is your slope-intercept form, where b is your y-intercept, your slope is a. I'm just giving you the general equation as if b is a positive number and a is a positive slope number. But the domain is all reals. And while I'm at it, I might as well give you the range in this problem is also all reals. Again, I'm just going to give you values of positives. So the absolute value function, which you've seen before, is shifted right b units, up c. So I'm just going to randomly put a thing here. And then let's say a is positive. The absolute value function is a v shape. Now, if you're looking at this, the domain is still all reals, but the range is a little different. Might as well talk about it, because the lowest point on this is, as I mentioned before, that's the vertex b comma c, right b units, up c units. So the lowest value is c, and it goes infinitely up. Now, the other thing to keep in mind is the range isn't always c is the smallest value, because imagine if this absolute value was flipped upside down, then the range would be negative infinity up to c. So some different things to remember as we move forward. And then this last one you studied a lot in Algebra 2. I'm just going to randomly give you a parabola shape. The vertex is not given to you as these values. Like, this vertex is very complicated to find from this. That's why you spend probably 9 or more weeks studying parabolas or quadratics in Algebra 2. So the domain is negative infinity to infinity. I might as well just give you the, you may even remember the formula for finding the vertex is negative b over 2a. That might ring a bell to you. And then, again, I'm assuming that a is positive, so it goes infinitely up. Yeah, and if you don't remember this from last year, we will cover those bases when we get to it. But this is correct. So I'm going to stop the video and keep teaching on the next one.